Given y equals x squared minus 4, find two parametric equations. First one, like literally, there's so many different answers for this. You could guess a whole bunch. But let's just say, for instance, that you had this and it looked like y equals t minus 4. Well, then that would mean that t is equal to x squared. Guess what? Or rather, x is equal to the square root of t. So these two equations would create that rectangular equation. Now, could this be done differently? Sure, we could say y is equal to t. And then we could say x squared minus 4 equals t, right? And we could certainly solve this for x and say add 4 x squared, or excuse me, x is the square root of t plus 4, like so. Lots of different ways that we could write this. That would be x and this would be y. So this would be one set of parametrics that would make this rectangular. Here's another one. Could there be another one? Absolutely. Could I come up with them? Sure, but you can too. All right. Okay. Janine runs at an average speed. Looks like a distance equals rate times time problem. Janine runs at an average speed of 8 miles per hour. So the distance that Janine has gone is 8 miles an hour times the number of hours t that she has ran. Okay? 2 hours after Janine leaves your house, you leave in your car and follow the same route. So this is your distance. We'll make this a y. Your distance. If your average speed is 40 miles an hour, but your time is not the same time, this t represents Janine's time. Yours is 2 hours less than that. Okay? So this equation represents Janine's distance. This equation represents your distance in the car. How long will it be before you catch up to Janine? Well, if we think about there's a couple different ways we can think about this, right? So like if we were going to do Janine's distance, she leaves here at t equals 0. At t equals 1, she's gone 8 feet. At t equals 2, she's gone 16. So this is, see if this makes sense to you. T equals 0, t equals 1, t equals 2, so on and so forth, right? All right. Okay. We could go again and say this is t equals 3, and that would be 24 miles. Okay. Now, you drive in your car. You start at t equals 2 here. This is your t equals 0. This is actually your t equals 1, your t equals 2, your t equals 3. Think about that equation. If you put a 2 in there, you're still going to get 0. That's when you left your home. If you put a 1 in there, excuse me, not a 1, a 3 in there, you will get 40 miles. Okay, so somewhere between t equals 2 and t equals 3, you and Janine would have gone the same distance, right? Because you basically surpassed her. So, don't overthink it. How do we find the t that makes them the same? Well, we set them equal to each other and we solve. 80 divided by 32 equals t. So t is equal to 80 divided by 32 is 2.5. Now, this is very interesting. The t, remember how t stood for Janine's running time? So Janine has ran for only 2.5 hours. You have driven your car for only half an hour because those first 2 hours, Janine ran, but you did not do anything. All right, equal to 2 plus t. Eliminate the parameter and write the parametric equation as a Cartesian equation, which is rectangular, which is an XY relationship. Okay. We just do this by substitution. So it doesn't matter which one you solve. If I solve the x equation for t, I will get x minus 1 is not squared equals t squared. T will equal the square root of x minus 1. I will say x has to be greater than or equal to 1. Otherwise, you'll have a negative under there. Okay. All right. And then I'm going to plug this into the y value or the y equation to eliminate the parameter. Y is equal to 2 plus the square root of x minus 1. Not only does x have to be greater than or equal to 1, we can see that y will always be greater than or equal to 2. All right, moving on. Same thing again, eliminate the parameter. Don't overthink it. We're going to do the same thing. This one might involve a log, though. Let's see. If x is equal to e to the negative t, let's put a natural log on the front of each one. Because if we do that, we can use log rules and bring this out front. Hopefully you remember your log rules. The natural log of x is equal to negative t times the ln of e. Well, we know that the ln of e is a 1, so I don't have to write that anymore. Okay. And now I have t is equal to a negative ln of x. Okay. I'm going to substitute it into the other equation so that I have just y and x. Y is equal to 3 e to the negative ln of x. I see other stuff here that I can clean up. If I take, I'm thinking log rules again. If I take this negative 1 and bring it up for a power, not there, bring it up on the x for a power, it really tells me that inside here we will have e to the ln of 1 over x, right? Because negative 1 as an exponent means fraction. Okay. Again, natural log rules. If this is base e and this is ln, they negate each other. This is going to be 3 times 1 over x. You might need to refresh your log rules to do logarithm manipulations. But this now is a Cartesian equation. Y equals 3 over x. Okay. Now, t always had to be greater than 0. And so if t was always greater than 0, e is a number, raising it to a power, whether it's negative or positive, that will also always be greater than 0. So for here, x is greater than 0. All right. Eliminate the parameter and write their Cartesian equation. Very, very similar to the last problem. I think we got so many options. We'll follow the same route. Wait, isn't this the same problem? Nope. Is it the same as this one? Nope. All right, it's very similar. But x minus 2 is equal to the square root of t. So t is equal to x minus 2 squared. Y is equal to log of x minus 2 squared. Remember the log rules that we discussed a little bit ago. You might have to review them, but this power of 2 can come out front. Like so. Okay. Lastly, find the set of parametric equations that are equivalent to this. So Again, when you're creating your own parametric equations, they can look different than mine. They could look different than to any other classmates, okay? But let's suppose I said t was equal to x plus 3. Then I could say x equals t minus 3. And I could say y is equal to t squared plus 1. So then this would be your parametrics. Okay? Now, could I have picked something else? Absolutely. There's many different ones. Another one we could say is t equals x plus 3 squared, which means then that y equals t plus 1, okay? And what would this mean x is? We'd have to square root the t, and then we'd have to subtract 3. There you go, there's another one. So there you have many different options. It just depends on which you choose for t.